Thanks, Nicholas. Hi, everyone. My name is Scott Barbick, and I'm CTO North America for Dataductus. And the title of my presentation today is Use a Robot for Network Automation. And the subtitle perhaps might be a little bit more insightful, a little bit more specific, which is getting more value from your NSO test automation. And you'll see the tie in just a few minutes. But first, a bit about Dataductus. We are a network automation consultancy with a long history of working with the BU and the NSO community. We've done more than 75 NSO projects and have more than 300 employees working in offices around the world. And we're very excited to be here today. I'm virtual, and I wish I was in Stockholm, but that'll be next year. All right, so for today's presentation, it's all about the context of NSO projects and automation. First of all, it's the motivation for automated testing. And with that, the core is getting more value by reusing your automated test framework to accomplish network automation tasks. For those who saw the word robot and showed up to hear about robotic process automation, that can be a topic for a future session. All right, so we'll start with a poll and to see what test automation frameworks might be in common use out in the field. And so while you're doing that, I'll just talk about the ones I've listed. The robot test framework, that is currently my favorite. It has a lot of value in terms of the higher level presentation of what they call keywords, and then a core of Python, which is really good. The PyTest, of course, JUnit, very common out there. And then Selenium is a way that people automate their UIs, and that works with either Robot or JUnit and certainly others. And then, of course, Lux. We've all used Lux for NSO projects. Okay, so why test automation for NSO projects? First, I'm going to come over here and go to my terminal and show you a successful test run. This test run is one of those that we run on our core, on the Dataductus core robot test framework. And you can see it runs a number of tests, and they've all passed. And what I'll tell you, in fact, there's some PyTest up there. So we use both. What I can tell you is that if you look at my command, which hopefully you can see, this is run against NSO 5.1 functionality, and that'll be significant in just a minute. So basically, here's a set of tests that runs it. It verifies the functionality of what I had going in an NSO 5.1 set of features. What I'm going to start running is I'm going to run the same tests against NSO 5.4 functionality. And for those who know what happened between 5.1 and 5.4, we'll see that in just a second. So that is running, and I'll come back to this. So why test automation for NSO projects? Well, NSO automation is software, and it's well established that finding a bug early in software is a lot cheaper than finding it later. And certainly you want to find it before you hit release, before you hit production or the customer networks. And the earlier you find it in conception, of course, in design and all that, it's a lot easier. And so test automation helps you do that. But that's about bugs. What we also want to consider, and it's very, very important, is that it's not just about bugs. It's also about changes in functionality. Whether you knew you were changing functionality or not, you need to find a way to verify that the behavior you expect is still the same behavior that will go out to that next level or that next stage of deployment, whether it's development, testing, or release. And so now I will come over here, back to my terminal, and see that we had a failure. Remember, again, I ran it first against 5.1. I ran it this time against 5.4. And if I were live, I would say, who knows what big thing changed between NSO 5.1 and NSO 5.4? And so let's find out. I scroll up here and I find the failed tests. And these tests weren't specifically testing for that, but what they did was they exercised the REST connection. And if I look, I can see a 404. And clearly then we all know that in 5.3, REST was officially taken out and no longer could be used. It was deprecated before. Cisco gave us plenty of advance notice, and so it's not a problem there. But it is a problem if you didn't notice that and you just went to 5.4 and you checked your connections, you checked your services and said, oh, through the CLI and said, oh, all my services are working. So that's great. And now you deploy it and all of your northbound interfaces failed because you were using REST. So it's very clear that it's not just about bugs. Those changes in functionality need to be caught too. And that's exactly what test automation can do for you. And then the way I like to see is continuous testing for continuous information. It's continuous information about how your system, your automation system is going to behave. And so with these automated tests, you can test them in your development environment and move those over to your test environment, and you're still running the same test or a subset, or maybe some more even. Moving to staging for acceptance testing, and then even in production, the continuous monitoring is something that can be done with your automated test framework, and that's really where we're going. So we've established that automated testing is good. So now how do we use it for more than just testing? Well, we'll start with an example. Verifying the HA status. This is something that I've done a few times in NSO projects, and here is an example. It's a little bit of a streamlined example for demonstration, but it's largely functional, and it shows you that you can have, and this is of course the robot framework, you can have these high-level commands that say verify the HA status. Here it's an LSA environment, and it breaks down to the RFS and the CFS, and you can execute against that. You can verify the HA, you can call those to the verify HA in the default state, and that's another keyword, encapsulates some more functionality, breaks it down a little bit, and then you verify each individual node status. And you'll notice here I'm trying to use the better words for some of the components in there, and we'll be going with those. So with this verifying the HA status, let's take a look at the key infrastructure bits that you've had to build into your test framework, or you'd have to have available in your test framework just to make your tests work. Well, the first one is this, we call it send to, and this is basically a way to send a command to something. Send it to what? Send it to a variable. This happens to be the variable NSO. Remember, this is a keyword. This is a function, a method in some sense, where we've encapsulated and we passed in the NSO name to address mapping as a parameter. And then, of course, you need be able to send a command in. So you have this basic functionality already to send to any device that you have in your inventory that you built the connector for and send it a command. You also can tell it what type of interface you want to use. In this case, it's a CLI. You can recognize the CLI command, and but you could have a REST prior to 5.3, or you could maybe netconf and even bash or some proprietary REST based thing to say OpenStack. And then here's, in this particular example, you show that it shows that you can do more than just a single device. You can, here, there's an active NSO, and this one's changing to send a similar command to the backup NSO. Okay, so that's the key infrastructure that you've already built just to do your tests. So how do we reuse that test infrastructure for automation? If I had another chance to do an interactive poll, I would say, what is the thing that you like doing the least with NSO manually? And I put up there update software, update packages, reload packages, things like that. But the one that I would vote for is resetting the HA state on a number of nodes. To go out to these different devices when power has failed on one, or it's crashed, or you've upgraded it, is really something I don't like to do manually. I did it a few times manually, and then I wrote this test, or this robot encapsulation of functionality. So this is really an automation enabled by the test framework. And so for those who don't know, I'll just quickly show you what you have to do just to take an HA node that after it has failed over to the backup back to the active, to your default state. You have to send a command to override the current slave to the active. Then you have to go and activate that on the NSO. And then you need a way to make sure that the sync has completed, because it's got to sync its database. And at least as far as I know, that isn't exposed in the CLI. So you have to go to the logs and make sure you see that in the log saying, yeah, sync is complete. And then you go over and then you roll revert on both the active and then the backup. And so, or the backup then the active. So you have to do all those commands just to get your HA back into its default state. So I wrote something to do it for me. And then what we show at the bottom is that here's where we actually reuse that exact command that you've written for your test automation. And there you can verify that it all worked correctly. So that's how you do one. That's how I jumped in and I did one just to make my life a little bit easier with the core bits of the test framework. So how can we do even more? Well, in order to answer that question, I said, well, what are the components of a test automation implementation that I might reuse? I've mentioned them along the way, but let me list them here. It's the multiple device access. I built ways to connect to iOS, iOS XR, Juniper, NSO, even OpenStack with the RESTconf, and these different interfaces. I built those already. Device inventory, I know what my test devices are. I probably had that in some sort of JSON file or some way to easily add to it. Obviously, configuration loads with either large templates or individual parameters. I need that because that's really what you do a lot of testing for. NSO access for the show, config, request, all those basic commands. You built those for the showing, for doing your testing of your specific NSO commands. Sometimes you'll build in bash SSH access as another device type and another connector. And then of course the XML and JSON data processing. Things coming back from NSO, from devices these days can come back in JSON or XML, and there are a lot of great tools that you can use to process those. And then if you have a UI, like I mentioned Selenium before, you might have built ways to encapsulate various bits of testing a UI that you can then take those and reuse those. So these are the components of a test automation implementation that, if I list them down here on the right side, you can see those. You can see these bits. And then on the left side, I said, well, what can you do with these various components if I wanted to do some standard test automation or network automations? And some of the things I mentioned as pain points before that might be in a poll. Device onboarding is one, package upgrade, OS upgrades. Of course, my HA state management is something I would do, but you can also do the health checks. What about the continuous monitoring in a production network? If it's read-only, it's pretty safe, and so you can do health checks just to go out and reach out into your various systems and make sure that things are running okay. But then you can take all these and use them for these other bits, put them together, and see what else you could enable with those with your test framework. So those are the individual components. And then I said, well, okay, well, if we try to put them together, can we really call it a network automation platform? Is that too strong a word? Or is it just a set of scripts that you could run and make your life a little bit easier? I thought maybe we could think about it a little bit bigger than that. And so I listed the types of behaviors that you need in a real network automation platform. And these are just the basics. And so you can see that device connectivity, configuration are in there. Of course, simple automations, but then really complex automations need to be enabled. And then a REST API and results database are core in these kind of test automation platform components. So with those, I said, well, okay, if you have a COTS, a commercial off-the-shelf system that is a workflow platform, you're clearly going to have all these things and no questions. And there's a lot of good products out there for that. If you pick an open source platform, you'll probably have to build your device connectivity and your configuration access and some of those components in the checking yourself, but you'll get the simple and the complex automations and of course the database, the results database and the API. So then if you want to use a test automation framework to do more of these things, clearly you're not competing against a real off-the-shelf platform. And even in open source because of the complex automations. I'm not going to be that aggressive and say that you could do that, but can you do many other things? Perhaps. And the device connectivity and configuration we've already talked about, so you can get those. Simple automations, probably because they're simple, for some definition of simple. But then the REST API and the results database kind of scratched our heads and said, well, yeah, we don't really have that. So then we set out to say, well, what happens if we built that ourselves? You could do it yourself. Can we end up doing that? So we, in fact, built a REST API wrapper for the robot framework to run against NSO implementations, and it has a results database. And I'll show you just a quick demo of that. It's a Flask implementation that calls the Python ability to run a process. And so that's running here, and I will show it with Postman. And of course, I picked my favorite HA to demonstrate that with. And so the first thing you need to do is go out and get what tests do I have available. I have exposed for this demo, we call them collections. I've exposed the verify HA status and the HA activate tests, which are then actions that you can use. And if I want to say, okay, well, the first thing I'm going to do is through my API, I'm going to go verify the detail of the HA verify. And again, I've already run this a few times, but here I hit it. I am in fact hitting the API here, and you can see from Flask, from the Flask log, and then if I go and run it, then I have this collection set up, and I'm going to hit send, and it's going to go and it's going to be running. And in order to do that, I'm going to send it again and see if it's still running. It's still running, and because these tests are asynchronous, so we had to have the ability to send a command, put the request for the command in the database, and then be able to poll, because again, REST is asynchronous, as we all know. And so there, in fact, it's done, and I can go look at the results. And it's indexed here by the database index for the simple case. And the tests ran, and HA is in the default state on the CFS and RFS. So that was all successful. And now for some future time, when I want to go reset the HA state or go activate it on a set of nodes, I can run this command. That's the detail. It goes out and it gets the doc string. If I need to activate it, I'm going to go run it. This is old. I'm going to run that, and I'm going to go try to see if its status. I've given it the ID, and again, this is all very simple and quick for you, but I'm running, and I'm going to probably be running for a little bit because it's more involved, and eventually this will finish. Now it's done. My simple Docker setup, and I can go check the results. Again, I'm giving it an index, and this has completed successfully. The tests have 0 errors and 0 failures, and it ran in nearly 20 seconds. So that's a case where I have built or I have available to me a REST API and a results database for my test automation framework. So I have many of the capabilities that you need to do a lot more with your test automation framework to do simple network automations that could save you some time and get a little bit more value out of that test setup. Okay, well, that is all I have for today. In summary, the important thing is that we really feel strongly about test automation for your NSO projects. As I said, NSO automation is software. It's very complex software. And in order to identify changes in behavior, whether they're from bugs or from valid functional changes, that is the real value for test automation. So you know exactly what is going out into production. But with that investment in your test automation, you can leverage that into some other benefits, such as testbed automation is a natural. If you have a complex setup from from development to staging, pre-production perhaps, and then into production, there are a number of servers there, a number of systems, and you could really leverage what you've done to access those and work on the maintenance of those or those tasks that you really just don't like to do by hand. UI automation is also possible if you built in something with Selenium and you use it to drive test cases. Just point it at something else, do a bit of work to drive some of the APIs or the UIs that drive your network. That's all possible. And then, of course, with care, actual use for your network maintenance and audit and monitoring is possible. So that is about it for today. I enjoyed this time, and I look forward to being back in person next year.